The ESP8266 and ESP32 were programmed as web servers, using either HTTP protocol or AJAX to achieve communication between client and server. In this video, ESP32 is programmed as a web server using WebSocket protocol, which enables synchronous real-time communication between client and server. Let's have a quick look at two popular client-server models used on the internet. We have HTTP and we have AJAX. In the case of HTTP, the client will send a request to the server, and the server will respond by sending the web page. Now, every time the client requests service from the server, the connection has to be established and the web browser has to be refreshed. In the case of AJAX, multiple requests can be made by the clients from the server without having the web page refreshed. AJAX is considered to be the father of real-time communication between the client and the server, but still, every time information is required by the client, a request has to be sent to the server, so there is still latency involved. The solution to real-time communication between the client and the server with small latency is WebSockets. A WebSocket is an internet protocol that allows real-time data flow by achieving full duplex bidirectional communication between the client and the server. A WebSocket is considered to be an HTTP upgrade because it uses the same TCP connection as the standard HTTP. Applications include web-based gaming, chatting, and some other real-time client-server communication. This diagram shows the ESP32 programmed as a WebSocket server. The client will enter the IP address of the server on the browser, sending what is called a WebSocket handshake signal, which is a HTTP upgrade request from the server. The server will then respond with HTTP 101, indicating that a connection has been opened and a WebSocket is established between the server and the client. And now we have an open connection between the client and the server, and this connection is persistent. Bidirectional messages can be sent between the two. The client will get data in real time from the server without sending any requests. This connection is closed when one side closes the channel. In this video, the ESP32 controller is programmed as a WebSocket server, displaying this web page on the browser. There is a clickable button here. When pressed, it will toggle the LED connected to one of the digital pins of the controller. Also, the status of the LED will be displayed on the button, either on or off. And now for a quick demo, noting how the on-off appears on the button as the LED toggles. Also observe that when one client clicks the button, the status of the switch on-off is sent to all connected clients. The sketch used in this project was written by Elastigma. I did some modifications to the sketch so that it works with ESP32. A link to his channel will be provided, and I recommend you check out his channel where he integrates microcontrollers and web applications. These header files are included to enable the ESP32 to become a web server and a WebSocket server using Wi-Fi. Web server through port 80 and WebSocket server through port 81. This header file contains the web page code, which is shown here. While this header file contains two functions, the first function is the handle function, which is executed whenever a client requests a web page, and the server will send the web page code. The second function, WebSockets event, is called whenever new data is received from the client. Let's have a look at the arguments of this function. We have variable num, which will store the connected client ID number. type will store the type of received data, payload will be the data itself, and this variable will store the length of the data. Pointer payload, which contains the received data coming from the client, has the status of the switch from the client side, so either it's on or off, and this value can then be used to modify the value of this Boolean variable LED on off. Either we set it to true or false. And then here in the loop function, we can use this either to turn off the LED or to turn on the LED. Inside the setup function, we connect with the router and generate the local IP address, and then initialize the web server and the WebSocket server, and also the WebSocket on event. And inside the loop function, using this statement, we keep the connection open between the server and the client. String LED status will have a value of either on or off, which will then be sent to the connected client or clients. Its value will depend on the value of this variable here. So if it's true, then LED status will be on, otherwise LED status will be off. So we will take the value of this variable and using JSON format, copy it into this string variable and then send it to the connected client or clients using WebSocket. After we program the esp32 as a WebSocket server, we come to a browser and we enter the IP address of the server. The client will then send a request signal to the server requesting the web page. The server will then reply by executing this function here, handle function, by sending the web page to the requesting client. And also the server will establish a WebSocket connection between the two. This function init WebSocket, which is executed by the browser, its purpose is to convert the incoming JSON text from the server and convert it to JSON object. This statement converts JSON text into JSON object. And now JSON object has a string value off, which is reflected on this class button. So now button has off appears here, and you can see it on the button itself, the text off. Next, the else statement is executed because the value of JSON object is off, and these two statements will set the background color and the shade of the button. Now when we click the button, this Java function will be called, which is this function here. Variable button will then have the string value of LED on off equals on. The if statement will be ignored because the value of class button is off. Then we send the value of button using WebSocket to the server. On the server side, WebSocket event will now be executed, and pointer payload now has the string value LED on off equals on. Now we split the string here into two parts. var will have LED on off and val will have on. Now this if statement becomes true, and this if statement also becomes true, and now the new value of LED on off is true. Inside the loop function, since the value of LED on off is true, the else is executed and the connected LED is turned on. And the value of LED status now becomes on, which is then added to the JSON text and sent to the client. On the client side, now JSON object has the string value of on, which then impacts this class button, which then affects what appears here, and we see the on the button itself. Next, this if statement is executed, and these two statements will set the background color and the shade of the button. Following the same logic, you can determine what will happen when we click the button again. In a future video, the ESP32 controller will be programmed as a WebSocket server to be used in a